So we're going to talk about inner source and how it works, how it should work, what you've learned, both good and bad. So before we get into it, can you tell me a little about Cornerstone and where it was before you started and where you were trying to get to?
So Cornerstone is an enterprise SaaS, providing enterprise SaaS solution. Has been doing that for last 21 years. We are an HCM provider, human capital management solution. We pioneer in the learning management system. Some of the or many of the Fortune 500 companies are our customers. We deal with massive traffic. There are peaks, right? When the hiring season is going on, or when the performance appraisals are happening, or reviews are happening. There are certain customers where hiring is insane throughout the year. So there is a massive load on our system. We are a global solution. We serve our traffic in about 196 countries in about 42 different languages. And we have customers throughout the globe, primarily in US and European geography, where we are the pioneers. So that's what Cornerstone does. When I joined Cornerstone about 5 years ago, we were a very monolithic architecture, a 3-tier monolithic architecture, web layer, middle tier, and SQL Server database. But ever since I joined, we introduced concepts of microservices, breaking things down. We knew the kind of traffic we wanted to grow. Monolith was not the answer. It has been starting to reach a point where we need to start breaking things down based on how complex certain parts of monolith are, or how resource consuming certain parts of monolith are, and break those down, which allows us to grow those certain areas of the system independently. In fact, about 3 or I want to say 4 years ago, we announced publicly that any net new development that we are going to do, or any major enhancements that we are going to do in our product, are all going to be on microservices. Now, while we started our journey with microservices, obviously the tech stack, we had to blow our tech stack, right? We introduced caching in Redis, we introduced messaging, we started leveraging different tech stacks. One thing we started to struggle was when we started to talk about introducing containers. When we wanted to introduce containers, when we were still in our Equinix data center, we're like, wait a minute, we can't end up building every single technology stack within our Equinix data center, which is where we started putting a lot of emphasis on moving to cloud and doing everything cloud first, which would give us a lot of these services managed out of the box, which saves us a lot of time and helps tremendously with developer productivity. So we are not spending time on a separate team spinning things up for us. So like 5 years ago, we were separate teams. Operations was a separate team, QA was a separate team, engineering was a separate team, and there was this traditional concept of hands off. You do something and then you hand off to another team. When we started our journey with cloud, we were very clear. We wanted to dramatically increase our developer productivity, which we saw when we started moving to the cloud. So 5 years fast forward, we have started breaking down our monolith into microservices. We are using almost all of managed services of AWS. We are very high on security and compliance. A lot of our customers in different verticals, call it banking, call it finance, call it government, call it European, call it what may, every single healthcare, we serve in every single vertical. By being in every single vertical, security and compliance becomes a big thing, which is where cloud, I believe, is helping us also, because a lot of these services comes with high security and compliance. A lot of controls are pre-applied, which saves us a lot of time when we are doing development, or when we are choosing a new tech to be introduced in our stack. So that's where we are right now, breaking things down into microservices.
And so how many developers when you started this process? How many developers now, approximately?
Sure. So when I joined Cornerstone, we were, I want to say globally, about engineering alone was about 300 to 400 people. And then we went through an acquisition last year, which was a company our size, Saba Cloud. And now our global engineering footprint is about 1,200 engineering.
Okay. Now, so you had separate teams, QA, ops, and engineering, when you were starting to make this transition. How did you think about those different groups? How were they organized? Was just one QA group, one ops group, one engineering group? And then how did that look with that number of engineers, if that was the case, or if there was different groupings? What was the good news? What was the bad news about all that stuff?
Right. So let's talk about good news first. Or let's talk about bad news first. I recently learned we should always say bad news first. So bad news was that if an engineer wanted to spin something up or even POC a brand new tech, they were always dependent on infrastructure team or tech ops team to provide them a virtual machine, which, because they have their own set of priorities, it would take them, I'm not kidding, it would take anywhere between 2 or 3 months to get a machine. A typical problem in a company our size. And this was not something new I saw. Where I came from, where I was CTO at Cinema Now, we had similar problem. So one way to solve this problem was either they automated everything for us, tech ops team, such that if I want a VM, I can spin up whenever I want. But I still did not have much control over the size of the VM, how much memory I need, how much CPU I need, what will work, what will not work, me not having access to most of the environment. Bad news, right? Developers do not like that. If there is an idea in their head, they want to try it out right away. So that was one part of the bad news. The good news on the flip side, so on the tech ops side, on the QA side, the bad news was, as you can only know, right? If you have worked enough in the industry, you know, even though we say QA is responsible for testing, there is still a disconnect between what developer is thinking while writing the code and what QA is thinking when doing the QA of the code, right? So there will be very often, there are certain use cases missed out because a developer knows in his head or her head why that use case was written, but the QA may not know about that use case. Invariably, we may end up missing testing that use case, leaves a quality hole in the product that is delivered to production. But let's talk about the good news, right? The good news in all this was, like I said before, in Cornerstone, security and compliance is very, very heavy, right? So from that perspective, good news was, as an engineer, I did not have to worry too much about securing or applying all the compliance controls on this, on any tech stack that I am using. Don't get me wrong. I do not mean to say here that an engineer is not responsible to write the secured code. The code that you're writing must still be secure, but security and compliance is beyond writing secured code. It's like, who has access to the production environment? How long do they have access? How are we auditing? How are we preventing our infrastructure from any unknown malicious employee or a user, right? So all that was taken care of by the technology operations team, including the documentation, the SOPs for that particular technology, where the engineers did not have to worry. All they had to do was write code. So that was the good news in that. Now,
what happened? Go ahead, sorry.
Go ahead. Please go ahead.
Oh, so an engineer writes code, they deploy it to servers, and it's magic for them. The tech ops team runs it.
Right.
But what happens in this old model?
But the problem with this old model is, anything goes wrong, an engineer is the last person to know. Where the flip theory is, engineers should be the first to know if something went wrong in their code. Because something goes wrong, there is a knock team, there is an SRE team, they are trying to understand something went wrong. Then they are trying to page like 20 different people trying to get hold of somebody who can help solve the problem. Yes, we have on-call engineers, everything, right? But you wake up an on-call engineer middle of the night, that person looks at the code and says, oh, wait, this is not our module's problem. It is somebody else's problem. That the other person says it is somebody else's problem. I would not say that happens as frequently, right? If there is NOC and SRE team has spent enough time looking or monitoring the system, they know exactly, not exactly, but they know where the problem areas are, right? But still, there will be a lot of times, even till date, we are not completely out of monolith. Even till date, we have this problem on which on-call engineer I am waking up, right? So the problem is, as an engineer, if you don't know what went into production, what was the configuration of that production box, what were certain parameters that were enabled, not enabled, all those things are not known to an engineer, which creates a big hole in my opinion. So I have been a very firm believer of you built it, you own it, right? Nobody better than the engineer knows how this code should function. And when I say how this code should function, I do not mean in terms of functionality alone, in terms of how performant it will be, whether it is secured or not, whether the static analysis was run or not, whether a dynamic analysis was run or not, whether my code does proper encoding of the query string parameters that goes through. Every single thing. If as an engineer, I have my lens into production environment, I will be able to solve the problems much better compared to somebody else telling me what the problem is.
Okay, so now you start out with this monolith, you start out with separate teams for QA, ops, and engineering, and you want to move to this microservices strategy. You want to move to this strategy of engineers build it, they own it. Talk to me about the steps that you go through to do that.
Right, that was an interesting journey. So when we started our journey, our first step was to make sure that we pick a product. When we decided that we want to be on the cloud, we said, okay, we want to see if cloud works for us. And when I say here works for us, does not mean that whether we will be able to deploy in the cloud or whether we will be able to run in the cloud or not. Whether an organization where security compliance is so heavy, where we have so many separate teams, how will we bring all of them on same page when we are running in the cloud? How will we build the culture of ownership and accountability? It was a culture to be built right from scratch, right? So for us, what we did, we said, okay, we are going to pick a product, a real product, which we want to deliver. And we are going to build that product from scratch in the cloud using as many managed services as possible and try to understand what that journey looks like before we spread it to rest of the organization. So we picked a product, we started building it, we started building in the cloud, we started using infrastructure as code, we started using all the good practices, if you want to say, of building in the cloud, following the best DevOps practices. All of those we implemented. We started seeing the results were dramatic, right? Something that we used to release to production every 3 months, we started releasing code every day. There was a bug, we could fix the bug that day itself without anybody knowing. When we started showing this to our product team, so mind you, it's not just engineering team only, product team also. When we started showing them the power of owning something that you built, or the power of building the DevOps way, building the CI/CD pipeline, deploying using that, it was like an eye-opener for a lot of people in the organization, which is where we started our journey to say, okay, wait a minute. If this is what we want, then the full ownership should be with the team that is building the product, which includes the pipeline building, the DevOps aspect, the ownership of NOC, SRE, whatever have you, all those functions. At that point, that was our turning point where we merged 3 organizations into one engineering org. We merged our tech operations, we merged our QA, and we merged our engineering. And then within engineering, we split the engineering into different product groups, which we started calling as different domains, taken up from Martin Fowler, where we started putting a lot of emphasis on domain-driven design, domain-driven thinking, and domain-driven development. Merging that organization was our first step, first foray into where we were headed in the journey.
Okay, so I get that with the new product, but you still have this old monolith, right? And you have this old monolith that you need to break apart. Talk to me about how you start thinking about that. And I'm interested in how you start thinking about the architecture components, that how you start breaking that apart, but then how you also get unconstrained with, hey, I've got this monolith, now I'm going to build this infrastructure microservices on top of that. How does that infrastructure build not constrain the microservices? So if you could talk about those two things for a minute.
Right. So let's talk about first our microservices journey, how we started that, where we started building first. So the first place with microservices journey we started building was, we cannot have every single team build certain framework aspects. Like, we wanted to make sure all our libraries go through a circuit breaker pattern. There was a concept of service registry, service discovery, right? There was caching library available out of the box, logging available out of the box, instrumentation. If I'm writing a microservice, my microservice must be able to instrument day one. As an engineer, I should not worry about those things. So first, we laid down our microservices infrastructure team, who started building all these pieces together. Back in the day, 4 years ago or 4.5 years ago, we started building what we called as Visual Studio templates. So we wrote a VS template which would spin up a microservice which will come bundled with all of these things together. Like, there is caching, there is service discovery, service registry, circuit breaker libraries. We also built what we called as domain client, which was responsible for the load balancing, which was responsible for fault tolerance. So we built all of these components first, started building the templates such that any team that wants to write a microservice uses this template, it spins up a microservice, and now you can write your code and still be responsible to merge the PR, deploy, all of this, which we further automated, which what we called as development kit. We also internally codename it as dev kit. Dev kit is a function or a tool that we built, which allowed engineers to go on the screen and say, okay, I work in this particular domain or this product area. Here is my Bitbucket repo. Here is a service I want to create. And my service could be just CRUD operations, could be CRUD operations with bulk operations, could be serverless operations. So we built a bunch of templates, or a CRUD operation on a Dynamo table versus CRUD operation on an Aurora table. So we started building those templates. What the power of that tool was, as an engineer, when I went to this tool and selected the template I want to build, all I had to do was just punch in the name of my service and select few things from the dropdown. As soon as I hit create, this tool created a Bitbucket repo for you out of the box. It took a template which gave you CRUD operations, let's just say that operation, out of the box, with sample hello world implemented in it. It took that code and it deployed that code all the way to development environment. It pushed all the code, created the pull request, merged it as auto, and deployed all the way to development integration environment. And it spitted out the Swagger URL for you. So as an engineer, for me, the service is ready to use. In the sense, I can start coding and everything else around that infrastructure is taken care of for me for free. I don't have to do anything. So once we started building that power, and I'll tell you why we started building this tool. We started building this tool because we started to notice the product team invariably would question, wait a minute, you want me to build this enhancement in a microservice, but in monolith, building the same thing takes me much lesser time. In microservices, it takes much longer time. So we started hitting that area first. How can we accelerate development in microservices first? so that nobody is coming me and telling me, I want to write code in monolith just because it is faster to write there. So once you build this framework, now engineering aspect is easy, right? Everybody wanted to jump on writing microservices. Everybody wanted to write on AWS. Then came the aspect of, okay, now I still have monolith though. There has to be a product roadmap which allows me to start carving things out from monolith into microservices. So like I said before, right, we decided to answer the second part of your first part of your question, David. All new enhancements, all new development is on microservices. For the existing monolith, we still have a monolith. I would not say our monolith has gone away. For our monolith, we started picking areas which are performance-wise very, very painful, which takes up a lot of CPU, which is very monolithic. We started breaking those pieces out into microservices. In fact, we did not take the full-blown feature and pulled out into a microservice. Within that big blown things, we started using small pieces into microservices. To give an example, we have a lot of back-end queuing processing that happens when you are in a learning management software. Because when a training is assigned to all your people, imagine if the training is to be assigned to 100,000 employees at the same time, there is a lot of queuing processing happening. And this is just one customer I am talking. We have 7,000 customers. So we started taking things out of, let's say, our MSM queue and started putting those pieces in SQS and SNS. We started leveraging cloud technologies, started writing data stream to Kinesis, which allows me to start breaking things down piece by piece, start taking that advantage. Now, the success will only come if you can show to your product team that, hey, look, even though you may qualify this as a technical project, but there is a huge product advantage that goes to the customers. I have learned that unless you can show a customer value, it is very hard for product team or even for customers to understand why we are migrating to cloud or why we are modernizing for that sake. If a customer comes or product team comes and says, hey, everything is working just fine, why do you even want to modernize? These victories are going to help. So we today, even till date, in our monolith, we focus one by one on areas which are either very complicated and need not be complicated, break those down into microservices, or we constantly keep identifying areas where performance is a bottleneck. Any outage, if ever it happens, we start looking into an opportunity. Okay, is there an opportunity to break this down into microservices? So that's how we try to address breaking down monolith.
Okay, so you've got this magic button you can push that creates a deployment platform. The platform team develops it for your developers. How many people do you have in your platform team?
So in our platform team, it is actually, it varies. It started, our platform team started, I believe, with about 10. It grew up to at 1.15-ish. But we also realized we cannot be in this model. We cannot have our platform team growing infinitely. Can't do that. So what we started doing, we introduced what we call as insourcing, where we started leveraging our product development teams to contribute to the components that were otherwise going to be owned by platform teams.
Right. This is what I want. This is what I want to talk about is you've got 10 or 15 people supporting 600 or 1,200. The infrastructure team provides leverage, but they're also going to be a bottleneck, right? And that's so that right. let's talk about a bit about that.
Right. So as you rightly identified, right? Number one, yes, they are bottleneck. Number two, they will have their own priorities that they want to work on, like our components. It requires regular maintenance to that. Then there are different domain teams who have different needs, and each domain team in their own right way the feature that they are asking from platform team is a priority. So first we started to say, okay, first things first, we started building what we called as the architecture community of practice, where we brought one architect from one or two architects from each product into a weekly setup, which we meet till date since last 5 years, what we call as architecture community of practice.
Let me pause you just for a second, right? So you've got this platform team. Did this architecture community of practice start simultaneously with the platform team doing this, or the platform team start initially building this magic push button?
So first platform team started building. So first we laid down platform roadmap.
Yes.
In the sense, until certain areas are built, we cannot unleash our platform to the entire organization. We partnered with one domain team, and there was this platform team who started building all the components. Components are ready. Platform team, domain team, one domain team is partnered. Now we have a car which we can drive now, right? But the challenge comes when you ask, now there is a second product team to do the similar development. But the second product team needs more things out of platform before they can start leveraging. The third product team would need even more things. So as we started to unleash slowly, this started to become a bottleneck, like you rightly pointed out. Platform team, limited team, bunch of priorities. They have their own features that they want to develop, and product team have their features that they want them to develop. So huge challenge, which is where we started leveraging or started forming architecture community of practice, where we said, okay, on a weekly basis, we are going to meet. Besides talking about newer architectures, newer tech stacks we want to bring in Cornerstone, we are also going to spend time going through what is the roadmap of our platform team and what is their priority right now. And
so
go ahead.
Sorry. So the architecture community practice, it's made up of architects from each team, and they essentially become the product owners for the roadmap for the platform team.
That is right.
Got it.
And in fact, we had architects also joining from platform team because they have their own needs, right? They have to finish their own pieces that they started. So in that community of practice, we go through our roadmap to see which one is priority and why. So a person can come and say, hey, we have this customer with this ARR or this bunch of customers asking for this. We need platform team to build it. So they have to make a case why it is a priority. That allowed us, to a degree, it allowed us to prioritize. But as you can only imagine, we would still run into conflicts.
So let me just pause you for a second. You've got this community of practice. You've got the platform team that's going to execute. Community of practice is creating the priorities, do this, do this, do this. Now there's a conflict, which is?
The conflict still remains is where three product teams at the same time are able to justify that their feature is priority, but we do not have enough people to build it.
Great. So now you're constrained by the platform team not having enough bandwidth to serve everybody.
That is right.
And then what do you do?
And then we go back and ask for more people, which we don't get, obviously. So what we do, we come up with this genius idea as a team. What if we start insourcing? What if we said, wait a minute, product architects, you are not less qualified to work what platform team is working on, and you have your product need and you are dependent on platform team. What if we broke that dependency? What if we allowed product team developers or engineers to contribute to the platform code? The approval of the code will still be with platform team, but now they are writing their own fate. In the sense, if they need a feature, they can contribute to the platform component. Platform team approves the pull request, and voila, they have their change.
Okay, let me pause you for a second. So platform built the MVP. People want new features. You have the community of practice. the community practice says, here's the order you're going to do things. Platform team is a constraint on doing them, and you say, great, here's all the code. It's inner sourced. Anyone can contribute to it. Awesome. To maintain quality, the platform team are going to do the pull request. They're going to review the pull request.
That's right.
Okay, great. Awesome.
So now we run into second challenge. Now we have so many product teams. Everybody is contributing to the code. Now platform team is still the bottleneck because they are the pull request approvers. So a pull request, which should ideally be approved within a couple of hours, sometimes could take a day or days because they are busy, and the kind of change that has been made, they want to spend some extra time trying to understand why this change was done. Or if a brand new component was written or a brand new extension was done, they want to assess the challenges that you can run into with this new component or new feature.
So we've moved the bottleneck from days to weeks to get a machine in the original model to days to get a pull request approved. So it's better, but we still have that bottleneck. Actually, it was first days to get the machine, then maybe weeks to get something the platform team to do. Now the platform team isn't doing all those. Now it's days to get the pull request approved. And so now, how are you solving that?
So now, to solve that problem, we said we are going to outsource even the pull request approval. So what we said, within each product team, we have qualified engineers, architects, principals in each product team. We are going to pick one or two based on how much contribution they have done, based on how much they have shown the understanding of the code and understand what it means to change a centralized component. Because remember, even if product A team is making a change to the platform component, that same component may be used by product B, product C, product D. So it is still a centralized component, right? So we identified people within product team who can be pull request approvers, which means if engineer number 26 is making change who works in product A, the architect of product A can approve the pull request because he is a platform champion, call it that way, if you want to. The pull request is approved locally within the product team. So now your entire dependency of delivery is contained within your own product.
So now, so if I'm in product A and I'm a developer and the architect in my team approves it, is that approval, is that pull, is that thing that was pulled, is that available to everybody? Or do other products architects want eyes on that before it's a generally released item?
Right. So it depends. In certain cases, if let's say I wrote a template or I wrote a piece of code, which is only and only used by my product. So in that case, in your Bitbucket repo, we do not add other architects as additional reviewers or approvers. But then there are certain pieces which everybody is using. For instance, our domain client that we wrote, which is responsible to register your service, discover your service, make a call to your service, implement circuit breaker. It's the heartbeat of our system, that component. Anything goes wrong in that component can bring down the system. In that case, so this is an extreme case I'm talking. In this case, there will be one PR approver from the platform team, one from the domain team, and another one from another domain team, such that there are multiple pair of eyes that have reviewed the code. And in some cases, there is a product architect from one team, product architect from another team, and they are the PR approver. So it really depends from components complexity on how many PR approvers we want and who are those PR approvers.
Who gets to decide that? Who gets to decide who gets to approve the PRs?
Sorry, ask that question again.
So a pull request gets approved by somebody. Who decides who approves the pull request, whether it's a global thing, so multiple people need to do it, or whether it's local and only one needs to do it? How does that decision happen?
So because platform team owns the repo, at the end of the day, they are accountable. They are the ones deciding that.
Got it.
But they don't want their component to be approved by somebody whom trust is a very strong word here, but if they do not trust somebody to be able to take care of certain components because it is of utmost criticality, they only pick handful of people to allow to approve.
Okay, so now, so I have this 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 community of the architects, right? And the architect community practice, and I have the platform folks. How many architects per developers, approximately ratio?
Per developer, we don't have the ratio per developer. We have architects per product.
Okay, okay. Well, here's the basis of my question is how do the architects stay, is it easy for them to stay attuned to the needs of the developers? So when they sit in the architecture communities of practice, that they know what should be, should be the next thing the platform team does, or do they not? And if they don't, then how do you think about that?
Excellent question. That actually leads to our another community of practice that we run, which we call as the developer community of practice. So like architect community of practice is the product definer for the platform team, we have a developer community of practice who defines the requirements to the product team, to the architects. So every other week, we have this setup of developer community of practice, which is open for all the engineers globally. Now, because we are a global team, we run a couple of community of practices, one for the local time zone for India, and one for and Europe, and one for US and New Zealand geography. In this developer community of practice, any developer can come and present. There are challenges that they are facing with these particular platform components, right? In some cases, they come and present an alternate way to solve that problem because nobody has time, even between all this. This does not mean the model that we carved together for ourselves still does not mean we are delivering everything on time. We always have time. We are able to do this, right? There is still going to be product development priorities and all that always supersedes all these things. So, but in this developer community of practice, an engineer comes and presents a problem statement with our existing development stack and how they circumvent the problem, or they are not able to solve that problem, and it's a huge developer productivity loss. So all the architects are attending that developer COP, which we call, and that injects into our requirements to the product team, saying, hey, look, here is a problem that all the engineers are facing that you don't know as platform team and we don't know as architects. But at the surface level, when they are doing the development, here's a bug. Or because these enhancements are missing, it takes them forever to do something. So that injects into our platform roadmap. Or sometimes the product team says, wait a minute, because now we can actively contribute, we are going to keep this in our roadmap. We are going to make this fix and get the pull request approved from platform.
Got it. Okay, so let me just start the stack again. We went from a tech ops group creating VMs took forever. We had an infrastructure group. They became a bottleneck. We inner-sourced the development. The infrastructure group would approve the PRs. That became a bottleneck. We had the architecture community practice we had the architecture community practice to decide what the infrastructure group would do. The infrastructure group became a bottleneck. We inner-sourced it. We allowed people that we appointed to approve the pull request. Now we have a problem with the massive things the architects know wasn't enough. And so we allowed the developers to request directly from the platform group if they couldn't do it ourselves. Great. So now we have an aligned to the developer needs. That's great. So that's one of our communities that we need to take care of. But we got this great security problem. You guys do. Multiple countries, different laws, different securities. There are other constituencies that need to make sure quality goes through. It's not just quality of code. What does that look like? How does that affect what gets built and how you think about it?
Right. It can be as crazy as you can think. Given in the world we live these days, where every country is looking for their own data sovereignty, it's a big pain, especially companies like us, which is in the human capital management space, where we may have PII, sometimes we may have SPII data, right? So data protection is our #1 priority within our organization. We spend a lot of time, energy, effort in making sure we are trying to build as secure and as compliant product as we can, which means a lot of times I spend a lot of time talking to our European customers, our banking customers, our healthcare customers, trying to understand what problems are they trying to solve. Understanding that problem, talking to customers firsthand, allows us to know, okay, what should our security and compliance roadmap look like? Based on what that roadmap is, those requirements are injected either into the product roadmap or in the platform roadmap. But with security and compliance team also, because it's a smaller team, we run into the same challenge as we run into with the platform team, right? Where they become the bottleneck, they become the pull request approvers, they become the bottleneck. So we leverage the same model for our security and compliance team. So if a security team comes and says, hey, we want these areas to be built into our code base. For example, let me take an example of IAM, right? Any changes that we make, IAM is identity and access management in AWS world. So any changes to the IAM policy could mean somebody either getting access, somebody either not getting access, or the access is revoked. That IAM policy, every single IAM policy that we deploy in our cloud infrastructure today is reviewed by our security team. We want to be very, very sure who is going to get access, whose access is going to be revoked, or any new policy written, is this policy going to have a challenging impact on the changes we are doing. For example, very simple policy, making an S3 bucket public, right? So those policy, we have our security and compliance team be the approver of IAM policies. And now we are back to square one. Security and compliance team becomes the bottleneck because they are very limited in number. IAM policies are happening. I'm not saying we are changing policies constantly, but we are deploying constantly, and our policies are at service level. Each service, each Lambda function gets its own IAM policy. So lots of reviews, very few people. So we spread the same development model with the security as well. We identified architects or engineers whom we actually call security champions. Like I'm wearing my own ITSec, I'm a security champion in my organization. So I become an authorized approver for this pull request for IAM policy or reviewing any architecture from the lens of security and compliance, from the access, disaster recovery, backups, monitoring, alerting, all those GDPR, all those functions are built and then approved within the product team so that they are not dependent on anybody else. So one thing we did was that.
Go ahead. Yeah.
Go ahead, because it's going to shift to how else we are solving this problem.
Yeah. Do you have formal policies for approving someone on a pull request reviewer team or security reviewer team? And do you have formal policies if someone's in the team not performing well, how to pull them off those teams?
Yes. So first of all, we are very, very selective on who can be security champions. No offense to anybody. Everybody understands security quite well, I think, but some understand better than the others. So we are very picky on who becomes a security champion. Once you are a security champion, so far we have not seen anybody being revoked being a security champion, but not to say that thought has not crossed our mind. So what we have done, every time we want to make somebody security champion, we don't just say, okay, from tomorrow you are a security champion. We have them approve certain IAM policies over a period of time, while the secondary approver is from security team. Once they have spent enough time, then security team sometimes comes with a recommendation that, hey, look, I know this person A who has been approving IAM policy changes, and last 1 month, 2 months, 3 months, I have not seen a single challenge coming in or single policy approved which was not in reasonable limits, or this person has always identified issues in the policies for the team to go back and fix it, even if it means his own team or her own team is going to be delayed with the development. They are giving priority to security. Some of those parameters are assessed, and then that person is made security champion. So far, we have not found a case where we had to revoke somebody, but if we were to revoke, these will be the same parameters that you are failing to identify these areas, or the security incident occurred, and now we'll have to assess why it happened. Was it a misjudgment, or something new came up, was not identified? So there are parameters, but so far, I would say, knock on wood, we did not have to revoke anybody's security championship.
Great. I had a question. Did you have something you wanted to add from the previous thing?
Yes. So what I wanted to add was that I spoke about IAM policies, right? Like many IAM policies, every service having its own IAM policy can be you are making a lot of people bottleneck to approve your IAM policies, right? So what we started to do was, we started classifying IAM policies into 2 categories. A category which is an infrastructure level IAM policy, and a category which is a product microservice level IAM policy. What we started doing for the Bitbucket repos, which were patterns around product development related Bitbucket repos, if there is an IAM policy inside that, we automated approval of IAM policies by injecting our own patterns of identifying what could be an impact for a certain change to happen. And for instance, if I work in product A, and product A has a service B, and that service B accesses, let's say, a Dynamo table or a SQS queue or an SNS topic, your access to that service must only be restricted to this Dynamo DB table, this SQS queue, this SNS topic. Once you start looking into IAM policies, you realize there is a pattern there. And once we started to identify that pattern, we said, wait a minute, we don't want every single IAM policy to go through every single human eye. We are going to automate this. So what we started doing, we invested some good amount of time in automating our IAM policy approval. And then once we were ready, we did it twofold. We said, okay, a human is going to approve it. Now let me run, if this was automated, whether the automation will approve it or deny it, or if it will deny, what are the bases of denial? So over a period of time, we made that algorithm better and better and better. And now a lot of our IAM policies are actually approved as part of our pull request approval process itself. Because
that's done by the infrastructure team? The automation was done by the infrastructure team, or the people?
No, the automation was done by security engineering team.
Okay.
We have AppSec team who was responsible for the automation. And then on top of that, so while they approved all of this, it was very clear that, look, being a human, you may miss out something somewhere, right? You can possibly not catch every single possible scenario. It's not humanly possible, right? So we started writing what we call as the cloud bots. It started as security bots and eventually became cloud bots. These are Lambda functions that sit in outside our main AWS account into our security and operations account. These Lambda functions are running across our entire account ecosystem, looking for anomalies for every possible resource that was modified. It's a Lambda, so on modification, it triggers the function. And this Lambda is custom for Cornerstone requirements, which is married to Cornerstone's compliance policies and SOPs. And we look for such anomalies, and we have automated the process to a point where, if let's say I'm making up a hypothetical use case, right? somebody created an S3 bucket, a brand new S3 bucket, and forgot to mark that bucket as not public. It's not possible in our ecosystem because we don't let you deploy an S3 bucket with public access policy, right? So let's say somebody did that. Somebody manually went ahead and did that, not knowing what they were doing. They thought it was a sandbox environment, but it was production, whatever reason, right? So this cloud bot is watching for that policy. As soon as it identifies, it actually creates a Jira ticket for that respective team. Based on the tags, it finds which team this bucket belongs to, creates a Jira ticket, automatically assigns to them. And actually, in this case, because it's an S3 bucket and marked public, it will go ahead and mark that policy back to private, and then in form of Jira ticket, assign the ticket to the respective team to say, hey, look, we found this, go and fix your bucket policy creation cloud formation template such that it is never public when you modify it next time if it happened accidentally. Or if somebody manually modified, we need to know why it happened. And there is a, we do the root cause analysis to try to understand what happened. But that's the framework idea.
Well, thank you. This was very interesting about the way you take large number of developers and give them empowerment and unconstrain them from creating infrastructure and then building teams that can build the infrastructure yet maintain the quality of it. So appreciate your time. And for those of you that don't know, Satinder and I have known each other for a long time. And if you haven't caught it already, he's an amazingly brilliant guy. And so thank you.
Thank you, David, for giving me the opportunity to share our experiences. Happy to, if anybody wants or anybody has any other questions, feel free to reach out to me on LinkedIn or through David. Happy to share more information.
Great.
Thank you so much.